Lesson 9-1, multiplying and dividing rational expressions. So now that we're in Module 9, what is Module 9? It's about rational expressions. What is rational expression? Well, if you break down the word here, rational comes from the word ratio. So we're taking a ratio of polynomials. Okay, so I'm seeing some fractions right off the bat here, right? Yeah, so ratios of polynomials. All right, so let's dive in some examples here. Simplify a rational expression. Example one, simplify a rational expression. So we got x squared minus 2x minus 24. Right, so there's a polynomial. Right, so polynomial name, right? Three terms there. Divided by 2x cubed plus 6x squared minus 8x. Okay? And so since it says to simplify this, that implies that there's a simpler way to write this. So, I do see that the numerator I can factor, right? So I could rewrite that as something times something, right? And the denominator, well, these three terms uh, each have an even coefficient, so I could pull out a multiple of two. And they also each have at least an x, so I can also factor an x out. I might be able to do some stuff after that. So yeah, let's see where this goes. All right, so starting with the numerator here, what are two numbers that say add to -2, multiply to -24? How about maybe something to 6 and 4? Yeah, let's try that. Let's try x minus 6, x plus 4. Right now, I can go backwards and FOIL and make sure that works. X times x squared. Yep. -6x, 4x brings you to -2x. Bing. -6 times +4 is -24. Bing. Yep, it's all there. So that factors like that. Okay. And if you didn't know that, then you could apply a quadratic equation and figure out from there you get, oh, x equals 6 and x equals -4 if you set this numerator equal to 0. And that can help you figure out how to factor that. But how about the denominator? So I pointed out a minute ago that I can pull a 2 and also an x out. So let me do that and see what I'm left with. And so if I pull a 2x out of this term, I'm left with an x squared, because 2x times x squared brings back to 2x cubed. Pull a 2x out of this, I get 3x. Pull 2x out of this, I get 4. It's just 4, it would be negative. So that. Right. Now I'm pretty sure I can also factor this this bottom piece right here. Okay? And since we're going to simplify this, I have a suspicion that whatever I factor this denominator into, it's going to match one of these pieces, either an x minus 6 or an x plus 4, which is going to eventually cancel out. Okay, so hence the simplification. But that's kind of what you'd be looking for a lot of these. So I'll leave my x minus 6, x plus 4 up on top, just where it is. Right, down here, see what, okay, well, I got the 2x already, so I'll just pull that out. Can I factor this? What could add to 3 and multiply to -4? How about -3 and -1? Right, that would be true, right? No, 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 no. That wouldn't be it. Um, oh, okay, how about -4 and +1? Yeah, yeah, that hurt. Here, let's try it. Let's do x plus 4 and x minus 1. I think that's what I'm looking for. Okay. Let me see if this works. So x times x squared. Bing. Negative x and 4x gives you 3x. Bing. 4 times -1 is -4. Bing. Yep, it's all there. And so this breaks down completely like this. Right? And so far, this expression, this expression, this expression, they're all the same thing. Right? But interestingly, look at since I'm multiplying two things on top and I'm multiplying three things on bottom, right? This right here and this right here are the same thing. So they could cancel out. So the simplified expression would just be everything I'm left with, which goes x minus 6 on top, and then 2x and x minus 1 on the bottom. Okay? So this should be the answer with one additional condition. See what we canceled out? See, there's a rule in math, you're not allowed to divide by 0. So what if x was -4? Well, that would have made this 0. So the whole thing would have been, the whole denominator would have been 0. Right? Even go back to the very beginning. If I plug in -4 for this x, it would come out to 0 down here. Right? I would actually get 0 over 0. Right? And I lost that information by simplifying. So I'm going to put comma and say x is not allowed to equal -4, right? So that I still retain that information. So that would actually be the complete answer. Should be this right here. Okay. Now, if you want to check your work, what you could make up an arbitrary number for x. I mean, x could kind of be anything, right? Or you could like graph this and get all different solutions. So you could come up with like pi, for example. And if you decide to use pi for x, you could plug in pi here for all these x's, and you would get some value. Here, I'll go ahead and do that. Here, let me show you guys what I'm trying to say here. So I have to put this all in parentheses on top and the bottom here. So if I do pi squared minus 2 pi minus 24, I group that together and divide by 2 pi cubed plus 6 pi squared minus 8 pi on the bottom. Right, right. So when x is pi, this value is -0.2124 something, 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 right? Okay, if I did everything correctly, then I should get the exact same value here. So if x is pi, let's see what happens here. If I do pi minus 6, group that together, and then divide by, okay, then supergroup all of this stuff. 2 pi and then pi minus 1. Let's see if I get, yeah, it is -0.2124 something, something, something. It's the exact same thing, right? Right. So what I did was I just picked a single value of x to show to you guys that, right, this original expression and the simplified expression are in fact the same thing. Right. Now let's see if your book came up with the same answer, including the x should not be equal to -4. Well, okay. They didn't include the x is not -4 bit, but that Alex may look for that, right? So look for that. But otherwise, they got this other part the same thing as I got. All right. So actually, they did right here. Part B, state when the expression is undefined. Yeah. So that would be where x is -4. So x is not allowed to equal -4. So that'd be right there. -4. Did they? Okay. All right. Example 2. Example 2. Let's simplify by using -1. So let's start out the same way and play around with this and see what happens. So example 2. I got 6x squared minus 5xy. Okay, group that. And then we got an x plus 2y. Okay, now we got two variables going on. We've got x's and y's. Okay. All collectively divided by, okay, got an x plus y here. And 5x, whoops, sorry, that's a y, 5y minus 6x down here. There you go. All right, so that's the starting expression. So I'm saying, what could I possibly plot? Well, I see these two terms, I could pull an x out, so I could do that. I think it's the only thing I could do to start with, so I'll go ahead and do that. Just pull an x out, okay? And then I'll get, I got a 6x minus 5y here. I got a x plus 2y, and then x plus y, and then 5y minus 6x. Okay. Okay. Now, and this is kind of the crux of this particular example. Look at these two terms right here, like this one on top and this one on bottom that are root. Okay? They look almost identical, but not quite, right? Here I got 6x minus 5y. Here I got 5y minus 6x. Right? They are the negative of each other. And what you're allowed to do, and I'll do this in pink ink, just right on top of this one, is you can pull out a negative. So if I factor out a negative here, then this could be negative, this could be positive, right? Like that, right? So the sign switch, right? Right. So you can distribute this negative either to this piece or this piece or this piece, right? In this case, just the middle term, right? You only multiply the negative one time, right? Right. And now this matches. This -6x looks like that -6x. This positive 5y. Well, that matches also. Okay? What that means is this and this, right, do cancel out. Okay. And what nothing else is going to cancel out. So the next step will be as simple as it can get. So the whole thing's negative. I've got an x on top. I've also got this x plus 2y on top. Right, multiplied in there. And then on the bottom, I just got an x plus y. Okay. Right now, my other condition is this 5y. here, maybe I'll do this over on the side here. I know that the 5y minus 6x, remember, is not allowed to equal 0 because otherwise I would have been dividing by 0 going back to the beginning. Right, so 5y is not allowed to equal 6x, or you could say some version of y is not allowed to equal to 6 fifths x, or vice versa. So here I'll just write that y is not allowed to equal 6 this x. We're juggling two variables, so it's a little more complicated looking. But that should be a nice complete answer right there. Right. Ba-boom. Yeah. All right. So pretty similar to the first example, right? And fun thing was, right, if you get a term that looks really similar, top and bottom, right? But maybe one's the negative of the other, you can factor out a negative, right? There's just be a negative comparison. All right. Okay, next one. Example 3. Multiply and divide rational expressions. We got 3x over 8y multiplied by 12x squared y over 9xy cubed. Well, really, yeah, everything you can just multiply across. And your book wrote it out a long way, right? Like, what is uh, right, x times x squared times y, right? But well, if you expand it out, there are really like three x's that are all being multiplied here. Everything's just multiplied, right? There's nothing add or subtract, right? So I can just shove all this together. But careful though, you know what? There might be a simple way to do this. Because I know this y has factors and this 8 has factors that could cancel out, say, factors of this 12. Let me break this down in terms of factors, right, with the numbers anyway. So like 8 could be, I'll just do 4 times 2. You could break it down a little bit more if you want. And let me handle the 12 and the 9 while I'm at it. 12 could be 3 times 4. 9 could be 3 times 3. Okay, so I took all the numbers. These numbers now look like these, and these numbers now look like these, right? But I still got the x's and the y's. Right, so I got x times x squared here. That's like x cubed. I got a y on top. And down here, I got a single x and 4 y's multiplied together. So y, like that. Okay. Okay. Now I can still simplify because it looks like those 3's cancel, those 4's cancel. And I am left with a single 2 in the denominator. Okay. Like, is 36 divided by 72? That is 1/2. That's another way to think of it. I guess you could have done it that way. Okay. And then some of these x, y's cancel too. Like this x cancel, boom. This y, one of those goes down. I said put it all together. I got an x squared on top. And I got a 2 down here. I got y cubed. That should be the answer right there. Make sure you look up the same thing. X squared over 2y cubed. Yeah, same thing. Same thing. Okay. Ooh, there's a question B here. So let's knock that out. They did a divide right here. We got 10d to the 5 over 6cd. Okay, and then big old divide. 30c cubed d squared on 4c. Okay. Now, when you divide a fraction by a when you divide by a fraction, I should say, okay, you can take the fraction you're dividing by and flip and multiply it. That's the first thing I would do. This is 10d to the 5 over 6cd, okay, multiplied by, and then just flip this guy. Put the 4c on top and the 30c cubed d squared on the bottom. It's the same thing. Right, now let's do our simplifying. Okay. Well, let's see and let's see. Could cancel. I got 3 D's on the bottom and 5 D's on the top. Okay, so 5 on the top, 3 on the bottom. I think it's going to reduce to a power of 2 right here. Okay, and then all these numbers. Like, all right, 30 compared to 10, this is going to reduce to just plain 3. And then 6 versus 4, that could reduce to a 3 to 2 ratio. Right, well, going that way anyway. Okay. Right, so here, that's a lot of peeking. Let's put all of that together. Okay. So I got this d squared right here. That's a single thing. I got a d squared. Okay. I've left with a 2 up here. And then down here, I got this 3 and this 3. Those could combine to make a 9. and then I got c cubed. I think that is the complete answer right there. That's good simplification. Make sure your book got the same thing. They got 2d squared over 9c cubed. Yeah, same thing. Right? Your book very nicely expanded all that out too, so you can really see it like letter for letter, like what's going to cancel and so on. Okay. Looks like they broke down these other numbers in terms of their factors. Yeah, so that's nice. Of course, you guys haven't book, so we're digging into the details of all those middle steps. You do that too. Uh, Example 4. Number 4. Ooh, we got a word puzzle. I like these. I do really appreciate that your book throws in a bunch of word puzzles because it makes these connections to like real world scenarios where you're using all this math. Manufacturer creates and sells rectangular planters, wants to compare the areas of the top sections of two potential sizes of planters. For some given measure x, the area of the first planter is, this crazy looking ratio. And the area for the second planter is a different crazy looking ratio. They do have the same denominator. That's interesting. Write and simplify an expression that represents the ratio of the area of the first to that of the second planter. Uh, ah, yeah. So if we're doing, here's the first planter. The area is x squared plus 15x plus 50 over x plus 2. Okay. And the second area, now we're taking a ratio, the first to the second. So notice I'm doing a fraction divided by a fraction here. This one goes x squared plus 30x plus 200 over x plus 2. Right? Looks like that. Okay. So we've got a fraction over a fraction. Now again, to remind you guys, if you have a over b divided by c over d, like this is the same thing as a over b multiplied by d divided by c. Right? You guys remember that? Pretty sure we did that. Look, even go back to the Algebra 1 review, like back in August in this class. Right? Yeah, that's what we're doing here. So I can rewrite this as x squared plus 15x plus 50 over x plus 2. Right, and then multiplied by, and then I get this x plus 2 flips up on top. And then over x squared plus 30x plus 200. Okay. Right. No, but a lot of you guys are anticipating. Right, that was always going to cancel. Now, what about everything else? Because this really feels like it wants to be factored, these other things. Like what could possibly, oh, I know 10 times 5 is 50 and 10 plus 5 is 15. Maybe that could factor that way. I could go x plus 10, x plus 5, right? Okay, so this is a different way to restate this, right? First outside, inside last. X squared, bing. 5x and 10x is 15x, bing. 10 times 5 is 50, bing. It's all there. Right, and then what about all this stuff? Hmm, how about 10 and 20? Ooh, let's do that. Let's do x plus 10, x plus 20. Because x times x squared, bing. Outside, 20x inside 10x, that makes 30x, bing. 10 times 20 is 200, bing. It's all there. Okay. And if you'll notice too, okay, so something multiplied on top, something multiplied on bottom. This matches this, so it cancels out. Okay. And you know what? If you had trouble factoring either one of these, but maybe you got one of them and maybe you got this one, for example, and I don't know exactly how to factor this one. I mean, think about the theme of this particular lesson. I'm probably setting up a lot of these so that a lot of these cancellations happen. So I would start hunting around for, could there be like an x plus 10 factor in here or possibly x plus 5 if that didn't work, but the x plus 10 did factor. Right. And what you're left with is just this right here. So this should be the complete answer. Just x plus 5 or x plus 20. See, it's not what yeah, that's what your book got right here. Same thing. X plus 5 over x plus 20. This is the complete answer right here. That's it. Because everything else canceled. I might tag on this detail. X is not allowed to equal -10. Almost forgot that. Right? That's part of the answer too, right? Because otherwise you'd be potentially dividing by 0. All right. One more example, then we'll go into some of the book puzzles. Example 5. Simplify complex fractions. I got a 3x divided by x minus y. Okay. And that's divided by another fraction. Well, I'm going to skip ahead a step because you guys just saw this. You guys just saw if you're dividing by a fraction, you can multiply by the reciprocal of the fraction you'd be dividing by. So multiply by, and then I got 6xy over something minus something. I'm going to put the 6xy down here, and then the 4x squared minus 4y squared. Yeah. You know what? Yeah, let's do it. Right. 4x squared minus 4y squared. Obviously, the 4 we're about to be factoring out, right? But maybe something else too. Okay. There's something else too. Actually, if you can think ahead a little bit, like see a couple of chess moves ahead, that could be helpful to see like where this whole thing could be heading. Like once you factor out the 4, like then what? Is there something else that could happen? And I'm really looking at this x minus y and thinking, what if it somehow factor what's left and this top one that it could cancel with that? That's probably where this is going to go on. Also, this x and this x probably want to cancel too. And so I think all that's going to happen. Let's try this. So we got a 3x on top. Yeah, if I really just make this one giant fraction at this point. I could pull a 4 out of this. Okay. And what I'm left with is x squared minus y squared, but really that's just x minus y, x plus y. That's what that is. Okay. And then down here I got it x minus y, and then a 6, and then x, and a y. That's all there. All right, cancel time. So x goes away there. That goes away there. Now the 6 and this 3 could reduce, right? So it's 3, and the 6 could turn into a 2, right? So 6 over 3 reduces to 2 or 1. Yeah, okay. And that looks pretty simplified. So on top I got a 4, and then x plus y. And then the bottom, oh wait, what am I thinking? The 4 and the 2 also reduce. I'm being silly. Yeah. All right. So let's reduce that too. Okay, so this 2 reduce. Okay. So we have just a 2 up here. All right, that's okay, right? That looked like a so that looks like a 2 on the camera. Yeah, close enough, right? A little wide out right there. Wink, 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 wink. It's more like a 2. All right, and then down here, I think I just got a Y. All right, is that what? Okay, now this one it looks like your book did not. Uh, oh no, here it is. Here, 2 and then x plus y collectively divided by y. Yeah, okay, that's exactly what they got right there. And I'm going to say comma and add one condition here. Or no, let's do two conditions. Two conditions. Because one of the things I canceled here was this x from this giant denominator. So x itself cannot be 0 because that's not immediately apparent from our simplified version. But that is true. Otherwise, we would have lost that information from right there. Bam. But also, uh, what about this part right here? X cannot be equal to y because that would have zeroed out right here. So we also have this condition of x is not allowed to equal y because you would have been dividing by 0 effectively in the original setup. It's like that. You know another way to check your solution, like on the very first example I did, I plugged in pi for x to show you guys that the original and the simplified version came out with the same numerical value. You could also graph these. You could open up Desmos. If I did it on this one, it'd be a little tricky because I got an x and a y, so maybe I could open up like I could say z equals this and z equals this, and then in 3 dimensions, these two would pretty well overlay on top of each other. I mean, they would look identical. Right? Yeah. All right. All right, so pick some highlighted ones here that I thought looked pretty good and representative of this lesson. All right, so let's tackle number 3. All right, simplify each expression. And also state where the original expression would be undefined. Yep, like we've been doing all along. I got x squared minus 9 collectively multiplied by x squared minus z squared. And then that's all divided by. And down here I got a 4, and then x plus z, and then x minus 3. All right, that's what we're starting with. And so I think on the numerator, this wants to be factored and this wants to be factored. So let's do that. X squared minus 9, that could be x plus 3, x minus 3. Okay. Of course, you could FOIL, F-O-I-L, and check that, but this would lead back to this. All right, and then very similar over here. This is x plus z, x minus z. Yeah. And then the denominator itself is already factored as much as it could be, so I'll just copy paste that. All right. And now look for anything that's going to cancel. It probably should be because, hence it would have made it into this lesson. That x minus 3 goes away. X plus z goes away. Okay, and everything else should consolidate to the answer. So x plus 3, x minus z, collectively divided by 4. Okay. Now let's add on our conditions here. So the conditions are x cannot equal negative z, because you would have been dividing by 0 here. Okay. Also, x cannot equal positive 3, because that would have made you divide by 0 there. Okay. So here's your simplified version with your restrictions. Just like that. Same thing. Okay, number 5. It's pretty similar here. 5. I got x squared, x plus 2, x minus 4, all divided by 6x, x squared plus x minus 20. Okay, so right away, I do want to factor this from the bottom. Okay. Yeah. Okay. This x squared I'm going to rewrite as x times x while I'm at it. So x, x. Okay. Got an x plus 2 and an x minus 4. Okay. On the bottom, I got a 6 and an x. Okay. Now, how do you factor this? You probably figured it out anyway, but if you needed a hint, one of the factors is probably going to cancel out with one of these up top, isn't it? How about 5 and 4? All right, let's do x plus 5, x minus 4. Okay. Because x squared, bing, negative 4x plus 5x, bing, 5 times negative 4, negative 4, bing, it's all there. Cancel time. All that goes away. All right, and we got these 4 pieces left. So those will consolidate to the answer. X plus 2 divided by, and a 6 and an x plus 5. Okay. Restrictions. I know that x cannot equal 0 from here or positive 4 from here. There's a nice complete answer. Oh, look at that. It's all right. Number 7. I got x squared minus 5x minus 14 over, oh, they did this one backwards. 28 plus 3x minus x squared. Huh. Yeah, let's see where we're going with this. All right, so how could I factor? Yeah. Yeah, there's probably more than one way to think about this or go about this, but it should all lead to the same answer. Right, so I know 7 times 2 is 14. Okay, all right, I think there's a way to do this with 7 and 2 here. Let's do this. Let's try x minus 7 and x plus 2, because I think that'll work. X squared minus 5x minus 14. Yeah, that checks out. Okay. Now down here, this one looks like it's all being backwards. So, but could, how about 7 and 4? But this x is negative. That's weird. Okay. Let's try 7 and 4. All right, and let's go put a positive x right here and a negative x right here. Okay, so okay. Now let's see if this works. 7 4 is 28. Bing. 7x minus 4x. Bing. Negative x squared. Bing. Yeah. Okay, so that factors. All right. Okay, so now what? Oh, well, look at this. This is x minus 7 up here, and this is 7 minus x down here. Right? Those could cancel. They're the negative of each other. So I have to pull out a negative first. Now, if I say pull a negative out of this, I could switch these signs. Okay? And now these do match. Now this is x minus 7, and this is also x minus 7. They're the same thing. So now, those cancel. Okay. Now don't forget, you did pull a negative out, so the whole thing's negative. So I got x plus 2 over this 4 plus x, I could rewrite as x plus 4. Okay. And then don't forget the whole thing's negative. And then I'll put comma, x is not allowed to equal, well, I think 7, right? Because if x was 7, this bit would be 0. That should be the complete answer right there. Right, just like that. Okay. Now, another way you maybe could have approached this is you could have taken this bottom term from the original, this denominator. You could have factored out a negative from the get-go and then rearranged it and made it x squared minus 3x minus 28 with the negative pulled out, right? And maybe that would have been easier to go about it that way. Okay, so different ways. Right. A lot of times in math, there's more than one way to go about something. Right. Number 13, simplify each expression. Got 64, a squared b to the 5 over 35, b squared c cubed f to the 4. Okay. Now it says divided by, and it throws me another fraction. I'm immediately going to swap that up. I'm going to say multiplied by, and then reciprocal of the second piece. So it says on top 12 a4 b3c. I'm going to put that down here. 12 a to the 4 b to the 3c. Okay. And here it's got a 70, so I'm going to switch that and put that up top because again, I'm multiplying instead of dividing. And then a b c f squared. Okay, so I already, just in copying that down, I already skipped ahead one step. And so got it. Right, now really everything's multiplied. Right? There's nothing added or subtracted. I could just make this one giant fraction at this point and think of it that way. Okay. I see some numbers flying around. I see some letters. All right, so what we're gonna do. Well, how could I eventually set this up to cancel? Okay. Let's see. 6, 7, that's how about I know 8 times 8 is 64. And 8 breaks down into 4 times 2. So if you do 4 times 2 times 4 times 2, let me show you guys. 4 by 2 by 4 by 2 is 64. Right, so that aligns. Okay, okay, I got a squared b5. Now the 70, I'm going to say is 35 times 2, which is going to cancel out with this 35 here. So that'll be nice. Okay. Got an a, b, c, f squared. Down here, yeah, I got a 35, b squared, c3, f4. Now 12 is 3 times 4. You could break it down more, but I know the 4 is going to cancel, so let's cut there. A, 4, B, 3, C. Okay, so I guess I'm playing with the numbers first. So got those out of the way. Okay. And so what am I left with in terms of numbers? We got 4 times 2 times 2, that's 16. Times 2 is 32 over 3. So this is like 32 over 3 times something. Okay. Actually, I should consolidate all the letters. Let me go ahead and do that now anyway. And so I got 3 A's on top. So go A cubed. I got 6 B's on top. So oops, that's B. B to the 6. Okay. Got 1 C and 2 F's. So C and then F squared. Down here, I got 4A. So A to the 4. I got 5 B's. That's B to the 5. I got 4 C's. C to the 4. I got 4 F's. That's F to the 4. I think that covers everything. Yeah, should do it. Okay. Okay, now a bunch of stuff can cancel. If you got A times A times A on top, and then A on bottom, most of it's going to cancel. These completely go away on top, and on the bottom you just have 1 A left. Okay. The B's, well, on the bottom they completely cancel. On the top you have 1 left. Okay. B times itself 6 times over B times itself 5 times. All the B's cancel except for 1. Okay. C looks like only 1 C is going to cancel, so this power of 4 drops to 3. And then the F's, well, 2 of those cancel, so that brings us down to 2. Because I'll show you guys that, just in case you didn't quite follow that. F squared is like F times F. F to the 4 is F, 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 F. You're left with just these two F's on the bottom, hence this F squared. Right? And that is really the thought process for all those other variables too. So I have 32 over 3 times what we got left here. I think it's just a single B on top. And in the bottom, I have an A C cubed F squared. And that is probably what they'd be looking for. That's a good answer right there. Right there. And there's the whole thing. Pretty good. What was that? That was 13. Let's do 15. That's a pretty similar one right here. I got 15 a squared b squared over 21 ac. Oh, okay, this one is straight multiply. Right? So I just copy it exactly as it is. 14 a 4c squared over 6ab3. Yeah. Okay. Uh, I know this 15 could be 3 times 5. I'll just break that down right away in terms of its primes. 3 times 5. 14, here I'll just pull the numbers out in the front. It could be 2 times 4. Sorry. Why did I say it? 2 times 7. Also, no. 2 times 7. Okay. All right. Here, I'll work with the numbers first. I know 21 is 3 times 7. And I know 6 is 2 times 3. Okay, so yeah, break down all the numbers in terms of their prime factors. I think these are all prime numbers at that point. Okay, now how about all the letters? Well, on top I got looks like 6a's, so that's a to the power 6. I got a b squared c squared. Okay. And on the bottom I got a times a, so that's a squared, and b to the 3, and a single c. Okay. Okay. Now what? So let's cancel some of these numbers. It looks like the only numbers I have left are 5 on the top and 3 on the bottom. So I've got 5/3 from something. And the A's, well, this drops to 4. The B got 1 left on the bottom. And the C, I got 1 left on the top. Okay, so let's put it all together. So it's 5 over 3. I got A to the 4C divided by B. That's it. 18, packaging. Yeah, I did want to fit in word puzzle here. Packaging plant quality assurance agent compares the surface area of the and volume of packages to ensure that the packages will be transported economically. The most popular package size is a cylinder with a height 18 inches. Define a variable. Okay, so this sounds a little open-ended, maybe a little imaginative here. And write and simplify an expression that represents the ratio of surface area and volume to surface area to volume of the cylinder. So it might be a good idea to start with a picture. So here's what a cylinder looks like. So some packaging, maybe it looks something kind of like this. And if it was transparent, you could present it. Right. And now we are locking in a height of 18 inches. So let's do that. Call this height right here. Height is locked in at 18 inches. Okay. Now, what was never specified was the radius. So I'm going to call that r, like as a variable. Okay. Okay, maybe that's something that's not immediately known, but maybe, oh, somebody forgot to measure it. Well, I can go back and measure it. And meanwhile, if somebody does all the algebra we're about to do, then as soon as we have a measurement, we can just pop it in and get whatever we want. Right? But by having a radius, now we have a way to find what is the volume and what is the surface area. And okay, they want ratio of surface area to volume is what they want. Okay. So what is the surface area of a cylinder? I'll just call that A. Okay. So what could that be? Well, it could be this circle down here plus this circle up here, right? Plus, uh, is it true like here, if you like roll this along, here I got a cylinder right here. If I roll this along, then like this whole surface like around would stretch out to like a rectangle. Okay. And if I had added those three parts, that would represent the total surface area. So I got pi r squared for the bottom plus another pi r squared for the top. So I could just say times two. Okay. Right. Plus, uh, and isn't this circumference right here 2 pi r? So the circumference equals 2 pi r. Right. And then that's multiplied by this height, which is locked in at 18 inches. So I'll just say times 18. Okay. So to show you guys where this is coming from. This is circumference. I will abbreviate that circumference. That's where I'm getting that bit there. Okay. These are the top and bottom. Okay. So, right, so there's the top and the bottom circle added together, hence the two right there. Okay. Here's the circumference, which is a linear concept, but the circumference could represent the width of the rectangle and multiplied by that by its height. Right. This is like a rectangle, right? So width times height. Right. Okay, so there's the area. Now, what is the volume? I'll call that V. So the volume of the cylinder. Yeah. Well, the volume could be this circle right here, which itself is 2 pi r multiplied by this height, which again is locked in at 18 inches. So I'll just say times 18. All right. So now we got an expression for the area, an expression for the volume. Which ratio again? Ratio of surface area to volume. Oh, okay. Actually, it's nice how I wrote it because I can just say this area divided by this volume. So that's this divided by this. Yeah, let's do that. All right. So the surface area compared to the volume is, let's start with exactly what I wrote. Got 2 pi r squared plus, and you know what? This 2 and this 18, I'll just call 36. So 36 pi r. Okay. And then divided by, same thing here. This 2 and this 18 could consolidate to 36. And I got a pi r also. Like that. Wait. I'm so sorry. I'm so sorry. I made a terrible mistake. Let me go back. Um, this is not true. Okay. I don't know why I did that. Sorry, this is pi r squared. Oops, oops, oops. Okay. Sorry. Yeah, the area of a circle is pi r squared. Yeah, it's always too long. Great. So that's this area, right, times that height. Okay. So I gotta fix this. Sorry about that. This would be 18 pi r squared. Okay, now we're back on track. Now we're back okay. Okay, so I do have two terms on top and a single term on the bottom. Now, can I pull anything out of that? Let's go area over volume equals, okay. On the top, I do see both these numbers are even, so I can pull out a 2. I got a pi I can pull out. They both have an r in common. And then say multiply by, and then in parentheses or bracket, I guess. I got a single r left in this term, and then plus, and then 18, or just 18, that's all, r plus 18. Right, and then in the denominator here, I got 18 pi r squared. Now 18 I'm going to break down to 2 times 9 so that these 2's can cancel. It's still got a pi, of course, and an r squared. Now r squared, well, that's really r times r. So one of these r's also cancels. So that's going to go like this. Yeah. Okay. Okay. And I know. Actually, can I put the answer probably right over here in this corner? I'll just say equals and write the answer right here. Because on the top, I just got r plus 18. And on the bottom, I got 9r. Right. And this is given that the height of the cylinder is locked in at 18 inches, then you can use this expression to find the ratio of area to volume, like surface area to volume. Help you figure out how we're going to pack these in big old cardboard boxes so we can ship these to grocery stores or whatever the question may be, right? Right. And then you say to an employee, oh yeah, you measured the height, but you didn't actually measure the radius. Go back and measure the radius. Right? And then after you do this math right here, and you're looking at it, right, you get this answer. Maybe that employee comes back and says, "Oh yeah, by the way, the radius is like 6 inches or something." You think, "Okay, great, I can plug that in. Boom, we got the ratio, and now we know how to ship these to the grocery store." All right. Uh, say simplified expression number 22. Oh, I got a fraction divided by a fraction. Now here, I'll remind you guys, if you have a over b divided by c over d, I can immediately rewrite that as a over b times d over c, which is exactly what I'm going to do from the get-go. So on top says a squared minus b squared over b cubed. And then I'm dividing by another fraction. I'm just going to say multiply by the reciprocal of this bottom guy. So the a squared pops up here. I got b squared minus ab down here now. Let's do like that. Okay. Now, how can I do some factoring here? Well, a squared minus b squared, I know that's the same thing as a minus b, a plus b. You could FOIL that out, it would lead back to that. Okay, I got a squared up here. Down here, I got b cubed. And then here, well, I could pull a b out of just a single b. And I'm left with b minus a. Okay. Ooh, now look at this. B minus a down here, a minus b down here. Those can cancel after you pull a negative out of one of those. So yeah, I'll do that next step here. And so I got a minus b, a plus b, and then a squared. Down here, I may as well consolidate these b's, make it b to the 4, because I got b to the 4. And then this b minus a, I'm going to pull a negative out and make it also a minus b. Now, those cancel. Okay. So the answer is, I'll pull the a squared to the front too. Why not? Doesn't really matter. A squared, a plus b, divided by negative b to the 4. Right, that's one way to write what should be the correct answer. Oh, I should say comma. A is not allowed to equal b. That was an important condition too, because otherwise you would be dividing by 0. Put that on. All right. Yeah, let's do a couple more. All right, so number 40, archery. Harold and Hinto are on an archery team. So far at practice, Harold has hit the target 7 out of 10 times for 70%. Hinto has hit 9 out of times for 90%. Ooh. Harold and Hinto each hit the target on their next X consecutive attempts. It was like next 5 out of 5 or whatever the X is. Write an expression for Harold and Hinto that shows their average of hitting the target at after hitting those next X consecutive attempts, if it's like 5 attempts or however many after. Okay, so let's do it. So let's go Harold. Harold. Okay. His percentage hits. I'll just call it Harold equals. Okay. So 7 out of 10 times. It was 7 out of 10. Okay. But we're gonna go another X attempts, right? For example, if it was an additional 5 attempts, then this 10 total attempts would become 15. And the 7 would jump all the way up to 12 because 7 plus 5 is 12 because he hit all those, right? But in general, it could be 7 plus x here and 10 plus x down here. Okay. And similar story for Hinto. Hinto, right, right. Now, the original 10 times he hit 9 out of 10. Okay. But then he keeps shooting more arrows. Okay. If he shoots X more times, he hit all X of those. So again, if he hit, shot 5 more times, he hit all 5, shows up there and there. Okay. So I think that's what they're looking for part A. Harold and Hinto, something like that. Part B, right, is simplified expression for the ratio of percentage that Harold hit the target compared to Hinto. Including those X consecutive attempts. Like the 5 times after the original 10 that they kept hitting the target. Okay. All right, so here I've got each expression set up. All I have to do is take the ratio. So the ratio, this is part B here. Harold to Hinto equals, I got 7 plus x over 10 plus x, and be divided by this expression. But instead of saying divide by this expression, I'm going to say multiply by, then reciprocal. 10 plus x over 9 plus x. Okay. Same thing as what we just did right here. I just did this step right here all over again. Okay. A ratio divided by a ratio is equal to, well, the numerator times the reciprocal of the denominator fraction. Okay. That's what I just did right here. Yeah. That's how those turn into this. Okay. Right. And I see what's going to simplify. Zoop, zoop, like that. So the ratio, how successful is Harold compared to how successful is Hinto? Okay. Now in this scenario, it doesn't matter how many times x is. It could be 5 times or 500 times. Okay. Hinto already had the lead, so so Harold will never catch up. um, yeah, given these conditions. Right? But how well is he doing relatively? This is the answer. 7 plus x compared to 9 plus x. It's always that simplified ratio. Okay, so that one's pretty fun. Right. Uh, I was using the example of what if x is 5. So let's try a couple of things. What if x is 0? That goes back to the baseline value, doesn't it? 70% compared to 90%. Now, what is 70 compared to 90%? That's like 0.778. So you could say that at least for the first 10 arrow shoots, Harold compared to Hinto is like 78% is effective. Okay. And that's what this shows too. 7 over 9. If you let x go to 0, it's the exact same thing. Okay. Now, let's say they shot like 5 more arrows each. And of course, they made them all because the book says they did. So 7 plus 5 would be 12. 9 plus 5 is 14. Okay. Okay, so now Harold, he's sort of like, as a percentage wise, catching up to Hinto. Right now he's like 86% is effective. Okay. But again, this could go on forever and he'll never match Hinto. Right? He'll never reach 100%. As long as they both keep hitting the targets. All right, one more. Let's do 45. We're just going to do part A on this 45 right here. Because yeah, I saw this garden looking, I was like, ooh, I need a garden. Anita's yard is being professionally landscaped. The final design will consist of a circular fountain, X feet in diameter, in square A, surrounded by a grassy area B, and a gravel pathway in C that borders the grassy area. Okay, so this picture, basically. The square areas will be centered on each other, shown in the diagrams. Square A will have side length at 2x feet, okay, which they didn't label here, but maybe we need that. Anita would like the lengths of the sides to be proportional. For what value of x will the ratios of the lengths of side square C to B be equal to the ratio of B to A? Yeah, all right, so yeah, let's just do that. Okay. All right, so redraw their picture and then maybe add on a little bit to it. I should be using the roller here. Make some nicer looking lines. And start here. Boom, boom. Okay. Now, just looking for consistent ratios, right? Okay. Now, what your book did say is that this original square A did have side length 2x feet. So go ahead and label that side 2x. Okay. Also, it tells you that this right here has to be 3 feet, and this, or sorry, that was 5 feet, and this right here has to be 3 feet. There you go. This is 5, this is 3. Okay. All right, so and what else do they say here? They want, here, if I call this side C and this side B and this original side A, which is like equal to 2x itself. She wants C to be equal to B to A. Okay. Next we'll have for what values of x? Okay. All right, I think there's enough. We can get this here. All right, so I know that side A is equal to 2x, right? Because they said that in the text right here. Okay. I know that side B is equal to side A, which itself is 2x, right? Plus this 5, plus also this other 5. Don't forget there's a 5 on each side. So 5 and 5 is 10. That's where I'm getting that 10. Okay. Now side C is equal to side B plus this 3, which is like B plus 6. Okay. Now, since I know what is B in terms of x, here, I should really just substitute that right away. Okay. So C is equal to 2x plus 10 plus 6, which is like 2x plus 16. Okay. So I'll go ahead and carefully scratch out this version of C. So now I have all my sides strictly in terms of x. Okay. Now let's set up this condition, this ratio condition, and just play around with it and see what happens. All right, so C compared to B. So that's 2x plus 16 compared to 2x plus 10. That should be the same ratio as 2x plus 10 compared to 2x. Like that. Okay. Now, one thing that jumps out to me right away, when I'm looking at it, is every single term is a multiple of 2. So it might help me if I maybe just pull a 2 out of this. There. Like if I pull it here, let's do 2 out of 2 here, and then a 2 out of 2 here. There. What am I left with? I got an x plus 8, got an x plus 5, I got a x plus 5, and then just a plain x. Right? And all the 2's cancel. Okay. So now I really want this condition to be true. Okay. Well, I could cross multiply. So multiply, multiply. Let's do that. Let's see what happens. Yeah, just play around with it, see where this goes. All right, so I got x plus 8 is equal to x plus 5, x plus 5. Yeah, this looks like it's heading towards something quadratic. So, let's keep going. I could factor this x in and get x squared plus 8x. And over here, I could FOIL this, get x squared plus 5x, and then plus 25. Okay, now this is going to probably carry on a few more steps, so let's bring out a new paper right here. Okay. All right. Now, I do want to get everything. Oh, you know what? Whoa, whoa, whoa. I just noticed something. Uh, this x squared could cancel. That's a huge simplification. Yeah, look at that. I might be able to finish this right here because I could just, see, subtract 8x over. Now that's interesting because if you subtract 8x over, here, this becomes 2x over here. Subtract over 25, you get negative 25. Okay. Now x should not be a negative value. So that makes me suspect that there's actually no solution to this one. Yeah, okay. I just checked the teacher's solution. That is true. There, or the teacher's manual. There is no solution. Right? They wanted you to see the same thing. You would get a negative value for x, right? So for this condition, you want this proportional yard with this ratio to be met. Yeah, there's no way for that to happen with this other set of conditions that they gave you. Okay, so yeah, every once in a while your book does does something weird like that. But all right, so there you go. So a wrap on 9-1.